Now you take this problem number 50 of your textbook. It says a dumbbell consists of two identical small balls of mass half kg each, connected to the two ends of a 50 centimeter long light rod. The rod is light, so we don't have to measure consider the rod in the system. So a dumbbell is, we know, this is a light rod. We know what is a dumbbell. And there are, in a dumbbell, normally the two masses are identical. This dumbbell says it's a 50 centimeter long. It is 50 centimeter long. That means 0.5 meter. And it's rotating about a fixed axis through the center of the rod. Through the center of the rod, it's rotating about the center of the rod, about a fixed axis. So naturally, length is 0.5 meter. So each side is 0.25 meter. This is also 0.25 meter. And it is also said each of the mass is half kg. That means 0.5 kg. This is also 0.5 kg. Good. So this is the dumbbell. Now, the dumbbell is rotating about a fixed axis through the center perpendicular to it with an angular speed 10 rad per second. So initial angular speed omega 0 is given. It is 10 rad per second. Next, what happens? An impulsive force. Student, be very careful. This is an impulsive force. I have seen that in this chapter, this is the only one numerical problem based on impulsive force. And you know that impulsive forces, normally we ignore the impulsive force effects because not many numerical problems we face in the school. But if you go for competitive examinations, there sure will be an example problem with impulsive force. And impulsive force problem solving is different than solving the normal forces. Now, what is impulsive force? Please go to your textbook once again. The force acts during such a small duration that applying the formulas like force equal to mass into acceleration, etc., doesn't always hold good. There's a different method of handling that force. An impulsive force of average magnitude 5 Newton. So acts on one of the masses. So there is a impulsive force of 5 Newton. And this impulsive force acts for a time of 0.1 second. Whenever there is an impulsive force, the magnitude of the impulsive force and the time will be given, and the time will be always very, very short. Now, find the new angular velocity of the system. Earlier angular velocity was omega 0. They are asking what is omega after the impulse. Now, once you understand what is an impulsive force, solving the problem is very easy. Let us first find out the moment of inertia of the system. That will be anyway necessary. Moment of inertia of the system is equal to mr square plus mr square, both same. So m is 0.5, r is 0.25, 0.25 whole square plus, once again, the same thing, 0.5 into 0.25 whole square. So altogether 1 multiplied by 0.25 whole square, that means it is 0.0625. This is the moment of inertia, kg meters square. This is the moment of inertia. Now, what is angular impulse? What is the measurement of impulse? Measurement of impulse, you should be rather remember, although you do not very often face these problems. Impulse. What is impulse? Impulse measurement. In linear motion, impulse is force multiplied by del t. And in angular motion, angular impulse. Let us write angular impulse. Angular impulse is torque multiplied by del t. Angular is designated by the letter capitals J normally, is torque of the force multiplied by del t. This is very important to understand. Now, what is the torque of the force? Torque is 5 Newton and the distance from the axis of rotation is 0.25. So it is 5 into 0.25 into del t is 0.1 given. So this is equal to 5 into 0.25 into 0.1 is equal to 0.125. This is the measurement of impulse. Also, go to your textbook. Also, impulse J is equal to the difference of angular momentum, L minus L0. Now, L is I omega, L0 is I omega 0. So this is omega minus omega 0. So what is omega minus omega 0? So omega minus omega 0, that is the difference of angular velocity, is equal to J by I. Is equal to J by I. J we have measured 0.125, 0.125, and I, moment of inertia, also we have measured 0.0625, 0.0625. This is equal to simple 2. So omega minus omega 0 is 2. Now omega 0 is given as 10 rad per second. So omega or final angular velocity is equal to 10 plus 2 is equal to 12 rad per second. See how easy it was to solve the problem. Only thing you needed to know or remember what is impulse and how to work on the impulsive forces.